I'm here today with a special friend of mine, Mr. Warren Jones, and he's going to be working with a group of sixth graders from Bridgeport, and he's going to do a demonstration on electrical energy consumption, conservation, and renewable energy, how energy changes from one form to the next. Let's check it out.
Good morning, everybody. Does anyone have any idea what it took to turn the lights on in your house this morning?
A light switch.
A light switch, and that light switch controlled something called energy. And the energy was in the form of electricity. Very good. This is a typical home, for example. The power company has to provide the power for you, and it has to be there. Right now, I am generating the electricity that this home may need. So as I turn one thing on, I notice that the generator has gotten a little harder to turn. And you might have gone downstairs and decided to turn more things on. Now we have 3 lights on, and the generator is even harder to turn because of more energy that is required. And now this is summertime, and the air conditioner has been turned on, and now it really is difficult to turn because of the amount of energy that is required. Now, as I turn some of those things off, then turning the generator becomes a little easier. I turn more things off, and it becomes easier yet. And if I have everything off, and then the generator is no problem to turn because I'm not providing the energy, I'm just making the energy available. Well, the same thing happens at home. The more things you turn off, the lower your bill will be because the less energy that you will use up. But for a typical home, most of our electricity comes from fossil fuels. Here in central Indiana, most of it is coal, but most of those coal plants are being converted to a natural gas because it burns a little cleaner. To give you an idea, the amount of coal and the amount of energy that a city requires, notice the size of this shovel here that was crossing I-70, that was being transported from one side of I-70 to the other side in order to follow the vein of coal. They were using up the coal so fast that they had to cross the highway to follow it to mine it from the ground. Notice its size compared to the cars and trucks on the highway. Notice the size of the off-road dump truck. Here's the driver down here at the base of the stairs that he has to climb to get into the cab and get behind the steering wheel. That coal is taken to a power plant where it's crushed up real fine to make a super hot fire. That super hot fire actually generates steam by boiling the water. That high pressure steam is sent to what they call a steam turbine generator. And what happens with that high pressure steam, it goes through that generator and through a series of blades that are attached to a shaft. When that steam roars through there, it makes the shaft turn. That shaft in turn is connected to a high voltage generator. That generator is what actually generates the electricity. So now we're taking the chemical energy of the fossil fuel and converting it or transforming it to electrical energy by rotating a coil of wire in a magnetic field. We got a set of magnets here. We've turned that coil of wire just like I was doing right here when I was able to generate the electricity for the house here, where they would do that at the power company, provide that electricity. That electricity is pumped up to several 100,000 volts and goes down what they call high lines. Several 100,000 volts. When it gets to your city, then it goes through another transformer where it is stepped down to about 13,000 volts, depending on the municipality, where it goes down the street. When it gets close to your house, it goes to another transformer on the pole that you could see out of your window more than likely if you look one direction or the other, and that's stepped down to about 120 volts. That wire right there is the wire that brings the power into your house, just like this wire is bringing the power into our house here. So, but now we are using up those fossil fuels faster than they were made. It took several million years to actually form those fossil fuels from decayed animals, plant life, and things like that underground and under pressure. So we're going to have to look at other means of generating or transforming energy, and we're looking at a category called renewable energy. Anybody knows what we're saying? What we mean by renewable energy? As far as we know, it will always be available. And that's practically what we won't run out of renewable energy as far as man knows. And so the two leading areas of renewable energy right now are solar and wind. So we can actually use the energy of the wind to generate electricity, or use the energy of light to generate energy. And I think in your text you saw where there were different forms of energy or different types of energy: light, solar, well, solar is light, wind, nuclear, the fossil fuels, and things like that. So, but the light and the wind are, as far as we know, will always be there. So right now, we're going to switch over to the fossil fuel electric company. That blue light indicates that we've switched over. Our fossil fuel electric company just happens to be a battery pack. So in essence, we are now converting chemical energy to electrical energy. Now, if you'll notice, and I'll try to tip this up for you so you can see that meter. As I turn more things on at home or in my house, you notice the meter starts to jump up. And notice when I told you how the generator was getting harder to turn, that's because more energy was required. I turned more things on, we have more lights on in the house, the meter has gone up even more. And now that it's summertime and we got to turn the air conditioner on, it really has jumped up because the air conditioners require a lot of energy to run. Now, since these things are now depending on fossil fuel, when we turn more of those things on, in essence, that means they need to burn more coal in order to provide all that. You notice how that meter went up? They need to burn more coal or gas or oil or more fossil fuel. So that further puts a drain on it. If we could come up with something that we know will always be there, like the renewable sources, and like I said, the two leading areas are wind and solar. So let's see what happens when we enlist the aid of some wind. That meter has started to go down. Can't very well show that and use the wind turbine. But as the wind goes up, you notice the meter has gone down. So that means, in essence, I've got some alignment here. In essence, now they can reduce the amount of coal, gas, or oil that they are burning, because now we're taking advantage of the energy from the wind. So we are transforming that the wind energy to electrical energy via the wind turbine. And so that meter has gone down, less dependence on the fossil fuel, we can take advantage of the wind. The only thing we have to pay for is the cost of the turbine itself, but the energy coming from the wind, we don't have to pay for. Okay? Now, another leading source of renewable energy is solar energy. And so we have what we call solar panels. These are panels that actually generate electricity from light. And when the sun or light strikes these panels, you notice how the meter has gone down. Show you that it is light dependent. Now the reason it speeds up a little bit is because we don't have the voltage is matched properly, and so electrically things aren't matched up properly. But that meter senses what is coming from the fossil fuel electric company, and it shows you that now it doesn't have to provide as much because we're able to use the aid of sunlight to generate some of that energy that is necessary to run the house. Now, we need some more scientists and engineers to help us out with this renewable energy and to help us develop better solar panels and better wind turbines and other forms of renewable energy. There's biomass technology and other things, and who knows what's coming in the future. But to look at the overall scheme of things in the world, for example, if we look at the world right now, we're looking at the solar energy, which from the sun, light hitting the solar panel generates electricity. We have our wind turbine. The sun strikes the earth and warms the atmosphere, and we generate wind. Wind turns the wind turbine, so we are actually converting the energy of the wind to electrical energy. We have our hydroelectric dams where we have water flowing from a high level to a low level. It flows through generators, generates electricity. We have our nuclear power plants, in which case we found out that nuclear energy is very powerful, but it's also very dangerous, and we're learning how to use that. And so we are now not building as many nuclear power plants as we were because of the danger. And then we have our fossil fuel power plants. And if you think of fossil fuel, just think of the earth as having three large containers in it: a container of gas, a container of coal, and a container of oil. Well, those containers are rapidly going down compared to how fast they were generated. So we have to look at something of a renewable nature in order to anticipate the future. So those are going, so we're using that. Now, all of that goes down into what they call the electrical grid. And that's the electrical wiring network that supplies all the cities, all the homes and buildings. They feed into the grid simultaneously. But now, at your residence, you can install a small turbine of your own or solar panels or both. And you can generate the power that your home needs, like we have right here. Now, if your home doesn't need as much energy as what these are capable of generating, you can sell that energy back to the grid. So now, if you look at your meter and never touch any of these items, but if you look at your meter outside, it's going around. The more things you have on, the faster it goes around. As you start turning things off, it starts slowing down, just like it was easier for me to crank the generator as I turned things off. It starts slowing down. Now, if your wind turbine and solar panels can generate enough energy or more energy than the home needs, then you can actually sell that excess energy back to the grid. And the power company will keep track of that. That'll reduce your bill. That'll also reduce our dependence on the fossil fuel. Now, the one thing about renewable energy, the wind is not always blowing, the sun is not always shining. So we got to come up with a means of storing that energy when it is available. So we have to come up with a battery technology. And right now, Indianapolis Power and Light is now building a battery facility at one of its generating plants on the south side. And it's small compared to the amount of power that they put out in the course of a day, but it's a start to possibly take care of what they call peak loads and take care of energy that's not available all the time. We can store that, and when it's not available, then we can use the battery to help supplement the grid. And so they are investigating that technology. This is also where we need your help. We need better battery technology. We're going to need some more scientists and engineers in order to improve battery or some form of energy storage. It doesn't have to be batteries. It could be giant reservoirs where you pump water up, drain it down when you need it. It could be, they're also looking at huge natural gas or salt caverns where they pump air into those and actually pump the air and then bleed the air off through special turbines to generate electricity. But we need some more technology to be able to store energy. Right now, the way I understand that the best battery technology that we have has 1/10 the energy density of gasoline. So you can see that this amount of gasoline will take 10 times its size in order to hold as much energy. So we need to get that efficiency better. And so that technology is wide open, and with more scientists and engineers, you can help with that and have a future in that field. But here's just a demonstration of what's in a wind turbine. The wind turbine has to orient itself to the wind, and there are techniques. That one has a vane on it where it orients it to the wind. That's this tail right here will help direct it into the wind. Others have sensors that it actually electrically will orient itself to the wind for its efficiency. Here's a small installation that's at a company that's not too far from here, I think over on Diane Road. Here's an example of those large turbines that are up on 65 that are feeding into the power grid for the power companies. These solar panels basically is a breakthrough in technology that was brought on by the space program. The International Space Station is powered by giant solar panel arrays. I don't know if you ever noticed it when you see a picture of that. And basically they rely on sunlight to power the International Space Station that's orbiting the Earth. It would be very difficult to transport oil, gas, or coal up to the space station in order to generate its power. So these panels are actually what charge batteries up when they're facing the sun, and then the space station draws off of those batteries when they're not facing the sun. So that's a big breakthrough in semiconductor use when they develop what they call photovoltaic cells, where a lot of electricity is actually generated from light shining on them. Okay. And so that's basically about it. We need to come up with better ways of transforming energy into other forms, and come up with better renewable sources. And maybe turn off the things you don't really need to have on at home. That lessens our dependence on the fossil fuel and the depletion of the fossil fuel. Only turn on the things you really need to have on. Turn off the lights when you leave the room. Turn off the TV set and the computer when you're finished with it. Close the refrigerator doors and things like that. Well, thank you.